Yeah, no, my dad always says, if you see me, put me to work. So I'm no good not doing anything. So thank you for hanging out with me, and I'm happy to do as much as I can with y'all. Thank you all, too, for letting me learn with your kids. I know that's not always an easy thing to let an outsider come in. You never know what's going to happen, but I can assure you, if respect is one of the values here, your kids are respectful, man. It is, like, I teach a lot in the U.S., basically, you're herding cats most of the time. Like in an hour-long session, maybe 20 you get to teach. The rest is just like, all right, shut up. All right, come back to me, everyone. Your kids were so well-behaved, so nice, and like, that is commendable. I cannot tell you how cool that is to see. So you all are doing an awesome job. They're doing an awesome job here. Thank you. And like you heard, what I was looking at with your students today was, so my focus is learning. How do human beings learn? I didn't really look at learning per se with them. I looked at what we call front loading to learning. How are you thinking about learning? Because the joke is, man, I could spend 5 years telling your kids everything they need to know about learning. Memory, attention, what do you got to do? None of that would make a lick of difference if they come at me with the wrong story. So they needed to know the first port of call is you've got to come at me with the right story. You drive your brain. Your brain does not drive you. We always think we're slaves to this, to our biology. That's not how any of this stuff works. Our brain adapts to us. Our genes adapt to us. What info are we asking of it? What demands are we placing upon it? That is what we will get from it. So that was my focus today, was to help them start to kind of think about, what is your learning story? How do I take agency over that? If I get that right, now we can say, cool, how do you study? Now you want to pass every test, you want to fly through university, here's what you got to do. But if I got that wrong, none of the other stuff would matter. So that's kind of what we focus on with them today. And hopefully they'll bring you some cool stories and ideas to talk to. Anyone get any fun stories yet at home? Yeah, some trees. And so you're like, oh, I guess we better show up here. All right. If you ever are scared, like your kids are telling you a story, you're like, there's no way that's true, just talk to me. I'm happy to walk you through it. If you're like, what are you talking to my kids about? We can do it together at any time. But tonight, what I want to look at with you all is this kind of idea of development, which leads into a concept of stress, which then bleeds into tech. So kind of a big night. Now, in case you can't tell, I'm stupidly easy. So anytime you want tonight, interrupt me. Throw your hand up, ask me a question. If there's something you don't get or some direction you want to go, use me. I am yours till the end of this session tonight. Use me how you need me. If you wait till the end, there's a chance I'll just go all night and you'll never get to ask your question. So if needed, just throw it in, and I'm happy to stick around afterwards as well if you have some more personal things you want to talk about. But have you noticed that your teenagers, how many of you got teens now, by the way? Congratulations. Have you noticed they're a little weird? What in the heck is going on with them? So that's where I kind of want to start with us tonight. Let's see if we can't just situate adolescence, and then we can have a think about kind of some issues with adolescence. So here's what I want to do. I want to take a look at brain development kind of from birth to death, then we can home in really on those adolescent years. To understand brain development, there are kind of three principles we need to piece together. Principle number one is here. This is your brain. That is a real brain, fresh out of a cadaver. That's what they look like. Now, for the longest time, we used to think the brain was just an all-purpose meat computer, right? It's an organ that thinks. Lungs breathe, stomach digests, brain thinks, and a story. What more do we got to know? But that can't really be the case. Otherwise, why would this work? Now, I'm going to play a quick game with you. What I'm going to do is I'm going to pop a bunch of colors up in this square. All you got to do as quickly as you can, say out loud what these colors are. Now, if you're a little shy, you can just say it quietly to yourself, but it's better if you try and do it out loud. What are these colors here? Green, blue, purple, green, blue, red, green, purple, red. Sweet, we know our colors. Rock and roll. Round two, I'm going to pop a bunch of words up in this box. Just read me these words as quickly as you can. Red, purple, blue, green, red, blue, purple. Wonderful. So you know your colors, you know your words, and you all know where we're going? All right, let's get this over with. Round three. I'm going to pop a bunch of words in the box, but each word is going to be written in a different colored font. Your job as quickly as you can, say what color each word is written in. So I don't care about the word. I don't need to hear that word. I want to know what color the letters of each word are. Now, again, out loud so we can all hear you. Let's see what happens. Here we go. Oh, no. Oh. And did you get it? Did you? Now, someone over here came out with way too much confidence. It was the red shit. All right, so if you got it, so this is our first principle. It turns out you don't have a brain. You've actually got dozens and dozens of different brains all chugging away, all doing their own job. So go back here. You see the word purple written in the color red. You've got one bit of your brain that likes what? Words. Does it care what else is happening in the world? I'm word bit, there's a word, I'm going to do my job. You got another bit of your brain that likes what? Colors. It doesn't care what else is happening. There's a color, I'm going to do it. So this is our first principle to understanding teenagers. We don't have a brain, we got dozens of independent brains, or modules. So the official term for this is modularity. We do not talk about the brain as a unified system. We think it's different modules or networks all chugging away doing their own thing. That leads us into foundation number 2. So pop quiz, what is your brain made out of? We're talking about the brain, so what is it made out of? Neurons. So what are neurons? Just cells. That's it. There's never be afraid of your brain. Some people get a little thrown by it, like, is it a fat? Is it muscle? Is it magic? I don't know. Never worry about your brain. What's your blood made out of? Cells. What's your skin made out of? So what's your brain made out of? It's the same wet goo as everything else. The only thing that makes the cells in your brain somewhat unique is they've got a bunch of crazy appendages, but at the end of the day, they're just cells. Now, does anyone know what is the only job that these cells, neurons, really do in our brain? Does anyone know? That's it. They just transmit messages. Bingo. So just think of neurons like little wires passing messages. So information kind of comes into all these arms, shoots down that long tube, spits out all these arms. So just think of them like wires passing messages. So this means when we talk about the brain, we don't really care about neurons. What we care about is here, where two neurons communicate, where a message goes from one into another. Now, does anyone know what are these spots called, these little points of communication? Synapse or synapse, that's it. When we talk about the brain, neurons, 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 who cares? Synapses, how is your brain talking? That's what I gotta know. Now the problem is here. It's a concept called neuroplasticity. Now have you all heard this term before? It's pretty popular. Let's just be safe, let's break it down. Neuro, we're talking about the brain, and plasticity. In this case, what does plastic mean? Changeable, malleable, moldable. So neuroplasticity says your brain can change. Now, when we say your brain can change, what do you think is changing up there? Are we growing more or less neurons? Is that the big change? It's our synapses. It's how your brain communicates. You get more or less output points, more or fewer input points. The way your brain talks is always changing. Now, for a while, we thought this was some special process, right? Like if you worked hard enough, you can change your brain. No, we now know this is going on all the time. Everyone blink. Just blink your eyes real fast. Congratulations, your brain is physically different after you blinked than it was before you blinked. Thinking about your brain just changing, guess what just happened? It's changed again. The moment your brain stops changing, guess what? Yeah, you're dead. So that ain't cute. That is how the brain works. And this becomes our second foundation. The brain, what we care about is the synapse, and our synapses are constantly changing based on our thoughts, based on our actions. This is one of the big things we learned today with the students. Now, the third foundation of understanding adolescence then is here, and I got to give you fair warning. If you took a course with me at uni, I would spend a week on this topic. We're going to cover it in about 2 minutes. So necessarily this is going to be a little dirty, but hopefully we can just wrap our head around the basics. Your brain has two different modes it can be in to process the world. One we're going to call bottom up, one we're going to call top down. Now what does this mean? To understand, I want to start with an example. Let's think of bottom up. Here is a commercial I used to watch growing up. Here is my example of what I mean by bottom up processing in the brain. Just watch this.
Have you tried not saying like every other word? Remember this teacher story? Yeah. I was like going down the hill and like this guy like cut me off and like there's a crowd and like and I was like, look, stuff either happens or it doesn't happen. Stuff doesn't sort of like happen.
Boom. Perfect commercial. Camera cuts left, camera cuts right, we're all having a good time. As soon as that car pulls out, where does everyone's attention go? Right to the car, you don't really have a choice. This is my example of bottom-up processing. Bottom-up says the world comes into your system and those signals drive your brain. They dictate what you're going to pay attention to, what you're going to learn, what you're going to build more memories for. So bottom-up is basically world-driven processing of the brain. So if bottom-up says the world can drive my brain, then top-down says who can drive my brain? And my example for that is here. Now, you all know, everyone in this room knows intellectually that that square in the middle on the top is exactly the same color as the square in the middle on the left. You all know those two squares are the same color, but I'm guessing none of us really see that. What does the one on top look like? Kind of brown, and how about this one on the left? Kind of orange, rust-looking thing. Cool. Now, all I'm going to do is fade that image out except for those two squares. I promise you I haven't doctored this. If you don't believe me, I'll put it into Photoshop. We'll go live. Fine. All I'm going to do is fade it out, but see if you can feel the moment when you push back and decide, no, that square's not orange. It must be brown. Here we go. Okay. Now, all I'm going to do is bring that image back in. I promise you, nothing about this is going to change. You can use any scientific tool you want to measure it, quantify it, bring me your physics, tell me all about wavelengths. It's going to stay the same, but see if you can feel the moment when you decide, no, that square is not brown. It must be orange. Okay. Now, real quick, just so we circle the square, why? What is it about this image that makes us think that square can't be brown? What's happening? It's light and shadow, right? Everything in this side of the picture's in light, everything in this side's in shadow. Now, we all have decades of experience recognizing that when something moves from light into shadow, the colors, the tones of that thing change. That's how this world works. And here this image does exactly what you think it should. Green changes color, yellow's changing color, red's changing color, blues, they're all changing color except for that. You know what it should be doing, it's not doing it, so guess who simply changes the color for it? This is my example of top-down processing. Bottom-up says the world can come in and drive my brain. Top-down says, yeah, but I can push back and I can drive my brain myself. I can drive my own perceptions. I can drive my own sensations. This, you can tell, by the way, why this would take a week to cover in school. The implications of this get really scary really fast and really powerful. But for our purposes, I just need us to recognize we've got world-driven processing and we've got self-driven processing, and they're different things. Now, this ability to push back, this top-down processing, is largely done, just to be simple, we're going to say by the front of your brain. And this bit of the brain does its entire job by sending out one message. All it does is say stop. It is a massive inhibitor. It turns things off. That's how we drive our own brain, by turning things off. Now, that's going to come back to hit us in a second. But real quick, here's what we got. We got three foundations. Modularity. You don't have a brain. You got dozens of independent brains all doing their own thing. Two, the synapse is all important, and our synapses are constantly changing based on our thoughts and actions. Three, bottom-up versus top-down. World-driven versus self-driven processing. Now we can put these together to make sense of teenagers. So real quick, I want to take a look at brain development across a lifespan, and then we'll zero in. So let's just start here. So babies come out of the womb, their brain is still growing, things are still going cool. Let's just jump forward to age 1 to 4, age 2 to 5. We've all had kids this age now. What are kids like at this age? Think back to those golden days. What are they kind of like then?
Wonderful.
They're awesome. They're the best. It only gets harder from here. But what do they do? Like, what are they like? They're curious as heck. They get into everything. They're very happy. Have you ever noticed, in our lab, we call them sponge brains. Have you ever noticed they remember everything? Like, you tell them a joke at age 2, they will tell it back to you at 4, and you're like, how do you know that? You told me. Okay, I guess I did. So what is going on in their brains that make them this kind of unique? So I want to show you. Here's a group of neurons in a 1-month-old. I want to show you those same neurons in a 4-year-old. Check this out. Boom. So what just happened? Did I get more neurons? What did I get a ton of? Synapses. Everything is talking to everything. So I want to show you the number of synapses in your brain birth to death. So NB, we're going to say that's birth. 100, we're going to say that's death. But notice we're really heavily weighted for younger years. We've got half a year, 1, then it starts to speed up, 5, 10, 15, all the way up to 100. Here's the number of synapses in your brain from birth to death. Check this out. Boom. Boom. Oh. No, was everyone shocked at the 65 down? I heard this. Oh. Yeah, we'll get to that tonight, I promise. But this, for the first 5 years of your life, the number of synapses in your brain explodes. If you have a 5-year-old, they have 50% more brain than you do. Now, why? Why, when we come out of the womb, would the brain just go, cool? Everything talk to everything. What function is that going to serve? What's that doing for us? Language, numbers, color, everything. Basically, when we come into the world, does our brain know what's about to happen? No. So how does it learn? It says, cool, bang, everything talk to everything. We have enough synapses to hold on to everything. This is where you get sponge brain. They will literally hold on to every smell, sight, taste, touch, sound, and the brain doesn't know what belongs where, so everything is talking to everything. I'm gonna put this smell with that lamp. I'm gonna put this taste with that fire alarm. Why? I don't know what goes with what. We're gonna do pure input. We're gonna sort all this stuff out later. So that's your sponge brain. It's basically all bottom-up driven. Just through exposure, that brain is taking it all in. It's right around age 5 or 6 where the brain starts to say, okay, I get it. I see how all this works, and then it starts to pull synapses back into adult levels. So what is being mirrored in the brain through this kind of, we call it synaptic pruning, what's happening in the brain here? That's where you're building your modules. This is when the brain says, okay, I get it. I'll take colors, I'll take words, I need to talk to you, I never need to talk to that bit of the brain, let's pull that back. This is where you get that real heavy organization that we tend to think of when we think about the brain. This is now when the brain gets it and says, cool, I'm gonna do this, let's talk, let's ignore this thing, we're gonna be fine. Well, that's cool, but that doesn't explain this. So far, so good. Why then do teenagers act so dang weird? It's because I kind of lied to you. When I said this is the number of synapses in your brain from birth to death, what I should have said is this is the number of synapses in most of your brain from birth to death, but one part's got to act different. What part is it? It's that frontal lobe. And remember, this is the bit of the brain that allows us to top-down drive the rest of our brain, and it does it by sending out one message. What is the only thing it does? Stop. It inhibits things. It shuts things down. So if this is the synapses in your brain birth to death, I now want to show you the number of synapses in your prefrontal cortex relatively from birth to death. Watch this. Zoop. Okay. So while the brain is blowing up and taking in all this stuff and then starts to organize itself, the prefrontal cortex is on. It's there. It's just not doing much. It's just kind of kicking it. It's right around adolescence where it goes, cool, my turn. Bang. And it just starts talking to everything. Now, why? Why would the prefrontal cortex all of a sudden explode? What function does this serve? It's exactly the same as here. When we came into the world, did our brain know what to do? So how did it learn? Gimme, gimme, gimme. Now that we've got an organized brain, does our prefrontal cortex know how to drive it? No. So how does it learn? Sweet, let's just start turning everything off and seeing what works. Let's see what happens here. This is how it learns its job. Now, question, when the part of your brain that shuts down the rest of your brain starts to go haywire, what type of behaviors might you expect? Like if I just started turning off way too much of your brain right now, what might you expect to happen? Save the inhibition. That's going to come in a second. That comes soon. Here's where we get things like lethargy, boredom, unwilling to communicate, unwilling to engage. Will you get off the couch today? Will you please do anything? Does any of this sound familiar to people with teenagers? This is where we think that behavioral set comes from. In order for this bit of the brain to learn how to do its job, it's turning off way too much, and we're kind of left with this, human being. Now, in all of her wisdom, Mother Nature realized, look, this is going to be a problem. Because if we're all hanging out as a family, and let's say a bear comes running at us, the adults are running, the kids are booking it, but the teenagers are going to go, yeah, whatever. And they're going to get eaten. So we need something to push through this shutdown to keep teenagers going. And in all of her wisdom, she landed on the nucleus accumbens. Now, this is a small part of your brain. You've got one on each side of your brain. Now, if anyone ever talks about your brain growing or shrinking, man, they're lying to you. Your brain doesn't noticeably change size. If your brain is growing or shrinking, go to the hospital. You're very sick. That's not what happens up here. But there are 3 times in your life when a specific part of your brain will change its size, and this is one of them. When the prefrontal cortex starts shutting off too much, the nucleus accumbens goes bang. And it goes from about the size of a pea to about the size of a grape. Now, what does this part of the brain do? Does anyone know what this is linked to? This, just to be simple, we're going to say is your pleasure center. Okay. Now, what types of behaviors would you expect in a human being when the pleasure center hypermatures and starts going haywire? Here's where you'll get impulsivity, or lack of impulsivity, excuse me. And no, what do I want? Which is the one I want? Impulsivity, not lack thereof. Crazy ass behavior, willingness to engage with new substances, willingness to engage with new people. Hey, put me in this shopping cart, push me off through, this is gonna be hilarious. Any of this sound familiar to you with teenagers? That's where we think we get this secondary behavioral set. When the prefrontal cortex kicks on and starts turning off way too much, the nucleus accumbens kicks on and says, yeah, but I'm gonna make everything feel real good. And that's gonna keep you motivated and keep punching through that shutdown to keep you going. So it's really weird. Like, the way I always like to think about it is like, think about emotions on a scale of 5 to -5. 5 is the happiest you've ever been, -5 is the saddest you've ever been, 0 is just neutral. As adults, we basically live at neutral. We're at 0. Man, you had a good day at work, +1. Fight with your spouse, -2. But we're just sitting here. Teenagers, if they're getting these little +1, -1 emotions, it's getting shut down by the prefrontal cortex immediately. It doesn't even exist. For teenagers, their emotions go +5, -5, +5, -5, +5, and this is in the span of like an hour. And this is the power needed to push through this shutdown mechanism and keep them going. So it's really wicked when you realize you will never love as hard as you loved when you were a teenager. You will never hate as hard as you hated when you were a teenager. You'll never feel fear, disgust, pain the same way. Why? Because we literally don't have the mechanism anymore. We don't need it. But they need it, and so that's where they're getting this kind of wild behavior. Yeah.
Hi, I'm just curious. So, the teenagers that, are the outliers that, maybe have a lot of motivation or maybe aren't as up and
Yeah.
Is that linked to just their brains are not undergoing these changes to the same extent as their peers, or is it something else?
Yeah, no, everyone will go through the same changes. It's just everything we're seeing here is an average of a wide bell curve. So there will be some people who go through it more, harder, faster. There'll be some who go through it slower, shorter, not as powerful. The same patterns will go on. It's just we don't know, like, the degree to which it influences your behavior seems to shift between people.
So if you're on either end of the curve, it doesn't necessarily mean that physiologically you're also at either end of the curve. It could be displaying itself differently.
Bingo.
It's not linked.
We still think the process is happening and the process has to happen. It's just we're dealing with it slightly differently. Yeah, what are you thinking?
So the same vein, sex difference then? Same kind of...
Sex differences, no. No. Sorry, not allowed to say that word anymore. That's verboten. No, it's yes. There are sex differences, absolutely. Not in this process. So we think that the only kind of shift we've seen is women tend to go in earlier and out sooner. Boys tend to go in later and out later as well. So it's the same process, just seems to be slightly shifted. And we can think about why. So here's something interesting. So go back to this graph. That's awesome. So that bump, that red bump there, that is adolescence. That's it. Now, adolescence is one of the funniest things in that it has a real hard biological onset, but a real soft sociological offset. So what is the onset? What is the thing that kicks that prefrontal cortex into gear, that blows up your nucleus accumbens? What's the signal that says time to go? That's puberty. That's hormones. Things drop, menses kicks in, you don't have a choice, it's happening. What then turns it off? What brings us into adult levels? I'll give you the secret. Your kid's brain will reset into adult levels, and I'm being a little flippant, but I'm kind of not, once you kick them out of the house. Now, I say I'm being a little flippant because there are some cultures where you live in your family house forever. You never leave. So it's not specifically that. But the idea is once a kid has to assume adult responsibilities within whichever culture they are in, that is the signal that feeds back and shuts the system down. So this means there are some kids in war-torn countries, 15-year-old kids, if I image their brain, they'll look like adults because they will have gone in and out of adolescence wickedly fast. Maybe their parents passed, they're now taking care of their siblings, they're in and out. This also means there are some 35-year-old men right now playing video games in their parents' basement, and if I image their brain, they're going to look like a 12-year-old. Why? Because they never had to shut it down. That's sorry. Could have been a girl as well. So now you start to see why might we have different. We think women enter menses before men enter their puberty. So that's the onset shift. Offset shift, we think women are forced to assume responsibilities sooner than men are in our culture. Ergo, they're going to come out of it faster while men just kind of drift out of it. So it's kind of cool when you realize at some level our job is to get them gone. Like, I love my kid to death, but our job is to handball them out of the nest. Otherwise, they will never fly. Now, that's both awesome and it's depressing at the same time, which means we've got to get them out. But I just think that's important to kind of recognize. They've got to assume responsibility. Otherwise, nothing changes. In a world of bubble wrap and safety mechanisms and ensuring that there's absolutely no friction whatsoever in anyone's life, that is the greatest way to make sure we never raise an adult. I love and I love caring. I just don't love it to the extent we've been pushing it. And it's becoming harmful now. We're overdoing it. I had a woman I used to work with. So I was in Australia for the last, 12 years. And a woman I worked with, I was teaching her about this. Her daughter was 33 years old, still living at home, just total nightmare. Sweet woman, just very, very underdeveloped. And I just kept telling her, we talked about this, like, kick her out. She's like, no, she's not going to survive. Kick her out. She has all these pills. She has anxiety. She's like, kick her out. She finally kicked her out of the house at around 35. She's like, I can't take it anymore. You're out. Within 1 year, if you'd have met that girl, night and day. She was totally awesome. She got a fiance, she had a job, she was working, she was off some pills. And she's like, how did this happen? I'm like, you got to do that. If you do not allow them to assume responsibility, do not be shocked when they do not take it. You want to know my favorite? Sorry, I could talk about this stuff all day. Here are two of my favorite statistics. And this is going to feed into what we learned about later. One, when we turn 16, so at least my generation, so I'm 42 now. When people my age, our generation, hit 16, guess what percentage of us got our license within that year of 16? High 80, by 19, we're in the 90s. Basically, all of us. You could not stop us. And when I hit 16, my ass was out of that house. I'm like, peace, Mom. Love you. Guess what percentage of 16-year-olds are driving right now in the U.S.? It was around 27 right now. It's like nothing. It's frightening. I think once you get up to 19, it goes up to about 48%. That's it. They are not driving. Why? That's it. Why would I drive when you're going to drive me everywhere already? Like, it sounds absolutely absurd, but there it is people are like, maybe it's because we have better public transportation. Yeah, because 16-year-olds love riding the bus. That's the secret. It's because they never had to worry about it, and they still don't. Now go back to our generation. We used to walk to school. We used to ride our bikes to our friend's house. Basically from 10, my ass was out of that house in the morning. My mom would say, leave the house. I don't want to see you till dinner. We were always going, but there were also restrictions. There were certain things we were not allowed to do. When you have structure like that, then you set aspirations. Within a structure, now I can aim to be more like that. You can't drive till you're 16. Let me just piss around. You cannot do it till you're 16. I'm going to get a tattoo, not till you're 18. I'm going to do this, not till you're out of the house. Then we start thinking, cool, I want to be old like you. I want to be able to do this. And we start to live. You take away structure, you have a free-for-all family where you're just taking care of everything and no one has to worry. They do not set goals. They have no desire to be like us because they don't even know what we are anymore. And so you get this just kind of stunted, very slow development and growth. So at some level, structure. If your kids aren't pissed at you for the rules you're setting, you're not setting enough rules. They should hate you for the rules you set. That's kind of the point. And if you're not setting rules, they're not bouncing ideas off of stuff. They have nothing to aspire to. Now, again, this is a spectrum. Some kids need less, some kids need more. We're playing it moment by moment. But that's our job, is to help raise adults, not to just make sure they're safe. They're going to be safe. My other favorite stat is this. So in medicine, in the emergency room, there's a statistic, I forget the official name, but we'll call it accidental injury. So it's like all those, you weren't in a car wreck, you weren't sick. I know all injuries are accidental, purposeful injury, but it's like you broke your arm falling out of a tree. So we'll call them accidental injuries. Since we've been recording data, one group has had hands down the highest level of accidental injuries. Who is it? Teenage boys. Bingo. They have skyrocketed above everyone else. Today, 50-year-old men are higher than teenage boys. And so everyone's like, oh, does that mean 50-year-old men are getting hurt playing pickleball? That was like, oh. It's like, no, 50-year-old men aren't getting hurt anymore. It's 18-year-old boys are not getting hurt at all anymore. Why the heck would 18-year-old kids not be getting hurt anymore? Real hard to get hurt when you're playing video games, unless you get a thumb strain. Real hard to get hurt when you're texting your friends and sitting at home all day. That statistic depresses the daylights out of me. Now, I don't want kids to break their arms, but I want kids to break their arms. Like, I do not wish harm on anyone, but at the same time, man, do something. Get out there, play, be crazy. Go break into someone's garage, go steal a beer. I'm gonna be mad at you, but cool. They're just not doing it anymore. And that's going to feed into this kind of tech issue we see at the end. Now, whether or not we think that's good or bad, I'm just one person. My opinions are just my opinions. But once with the stats, you deal with it how you want to. But I just think these are things worth knowing and thinking about. And then we can start making decisions around there. Now, one last thing I want to point out before we move on to the stress issue is that kind of... So we're cruising. We hit around 65, 70, and what happens? The inevitable decline into senescence. Now, for the longest time, we thought that dip was biological. That you just got too old, your telomeres are dying, sorry, this is what old age is. We now know that is sociological. What do we do, most people at 65, 70? Retire. And what do most people do when they retire? Nothing. Not a dang thing. And if you're not doing anything, what's your brain going to do? Sweet, why would I waste any energy on this? Let's pull this back, you can save it somewhere else. Like my dad, he retired a couple years ago. Golfs, eats, watches Fox News, yells at TV, calls me, yells at me, goes to bed, does it all again tomorrow. That's my dad. Thanks, Dad. But literally, if he keeps doing that same thing all day, every day, what are we seeing in him? Just cognitive decline. The dude can't remember things as well. He can't remember names, can't remember numbers. He stumbles over words. He's like, I'm just getting old. No, you're just not using your brain anymore. Which means if you want to keep a healthy brain into adulthood, what do you have to do? Keep learning. You have to keep learning new things. It's not about like, people say do a crossword every day, do a Sudoku every day. You do a Sudoku every day, your brain will hold on to Sudoku bit. It's still going to get rid of everything else. It's not about picking one thing and going. It's about picking new things. Yeah.
That's cool. All that's super cool. And also, are you telling me that age has zero impact on synapses and brain? So if you have the ideal me, I'm the ideal aging adult.
Yep.
I do 5 PhDs and volunteer and learn another language, and I keep going.
Yep.
But my brain in 20 years or 30 years is going to look like my brain today.
Yep. Your brain should outlive your heart. You should die here, not up here. So long as you keep pushing. We've never seen, like, people talk about plasticity slowing down as you get older. Are you alive? Then plasticity can't slow down. It's like saying blood flow slows down. No, is your heart pumping? It's all going the same direction. So no, this should outlive this so long as you don't get any neurodegenerative diseases. You get Parkinson's, Alzheimer's, FTD, different ballgame. All things being equal, yep, keep it going.
How about processing speed? I'm thinking about I'm almost 57.
Yeah.
Menopause, hormonal changes, et cetera.
Yep.
Brain fog, all that wonderful stuff. So does processing speed change? Even I can feed my brain like crazy. Unless you get
MS, no. Right now you're in a very unique spot just because you do have a ton of hormones. Baby brain is similar, post-baby brain is very similar. You will come out of the back end of this and you will look exactly the same as when you went in. It's not that the brain is changing, it's just flooded with so many other things right now. But yes, it should, by all means, there's nothing about this that should go away unless you stop using it. Why? What happened? Oh no. Baby brain?
There's light at the end of the tunnel.
Oh, there is. You will come out of it. That is, yes, there is an end to it. And when you come out of it, you will like be like Diane Lane in like book club, and you're gonna go to Italy, and you're gonna have some fun, and that's it. And that's when the old flings show up, and they happen to be chefs, and you're like, whoa, what are the odds of this? This feels too good. It does end. Yeah, what are you thinking?
I really like this idea, but I think a lot of the parents here, like, probably have multiple degrees, and like we work in very high, like very challenging, mentally challenging jobs. And,
Yep,
like,
yep.
But I feel like I'm suffering mental deficits, and it's not because I'm not reading, and not because I'm not talking about complex ideas.
Yeah.
So I'm just trying to think.
Well, so you got two options for that. Either one, there is precursors to a neurodegenerative disorder, in which case we got to deal with that kind of separately. Or two, you happen to be living in a world flooded with way too much information. That's the tech problem. Everyone is clouding judgment right now. And it's not because we're getting stupider, it's because when was the last time you had a moment to stop? This is the technopoly. We'll get into, I'm writing an article on how deep it goes, but basically, the biggest problem we have in our generation, like everyone thought information was the God. When we have more information, we will solve every problem. More information is the key to everything. Do you think the reason why we still have hunger is because we don't have enough information on how to grow food? No. Do you think the reason why we're still having wars in the Middle East is because we don't have enough information? It's the biggest problems we're facing right now are not information problems. They're beyond that. But the problem is, once you get to a certain level of information, everyone thinks information is only good. It becomes really bad, and you lose coherence, and you lose any through line. You lose any semblance of normalcy, of what is all of this supposed to mean. Now, historically, we've had social institutions to help us organize that. Church says, here's what matters, don't worry about any of this crap, here's how this all fits together. School comes in and says, here's what you study, here's what you don't. Don't worry about astrology, don't worry about Dianetics, the information exists, but we're going to cultivate information to help you make sense of the world. The internet comes along. Now school collapses. Now we're left with what? What is organizing our information? Politics? TikTok? Nothing is organizing our information anymore, so it's just a constant stream of shit that we don't know where to put, and so everyone is starting to feel overwhelmed and we can't think. You read a book, you can't remember anything you read from that book. Why? Because you're getting stupid? No, because you immediately jumped into another book and started cramming in different information, and there's no coherence to anything we're doing anymore. So that's where I'd say the other option is you're just stuck in a society which is not favoring deep thought anymore, and we're surrounded by means that are just forcing us out of any coherent way of thinking, which scares the daylights out of me. But does any of that sound somewhat reasonable? This is our problem right now.
The people I work with, like, we're not, doing some repetitive movement all day. Like, we're reading, writing, talking about complicated ideas. But
Yeah.
people my age, like, we're finding it hard to remember the name of somebody, or remember, like, oh, I wrote this. Oh, I guess I did. My name's on it.
Yeah. It could also be an attention thing. There are dozens of reasons. Like, a lot of people say my brain is deteriorating. There's dozens of reasons why it could be happening that have nothing to do with the brain. Even just attention. I mean, look, no offense. I didn't get to 42 for being an idiot. So, and I don't know anyone's name, basically. So why would I start now? Like, there are certain, as you get older, you start to recognize what seems to be meaningful, what doesn't. And you start to really kind of block out certain things and home in on other things. Here, this is kind of a stupid example, but I wrote a book, I sent it to my mom. And I said, Mom, I wrote a book, hey. She sent it back to me with a note that said, I already know everything I need to know, thanks. That's my mom. So I think she's hit that point where it goes, I wouldn't have gotten this far if I wasn't working well. So why would I cram more stuff in that I don't need? I know what I need to get through my days, and she just basically stops trying.
A lot of us work in industries where we are constantly learning. Like, the technology is changing, or like in medicine, there's new developments in law, there's new developments in business, there's new developments.
If you still feel like you're losing it, we'll talk. I'll give you a neuropsych eval if you are. If it seems like you're worried about this, I would just no, that's fine. I would get an eval, and it could be that, it could be nothing. But the point is, what we understand about the brain is it's not just because you're getting old. The telomeres in your brain don't seem to be the thing that's killing your brain.
I'll disclose this because I'm probably not the only one, but in my 40s I was diagnosed with ADD, which I never had.
Yeah.
And
How did that happen?
but my brain is working 24/7 at a very challenging job. So it's when I
There you go.
it's exciting.
I just solved your problem. That's it.
But I've also read it's not connected to.
And you've read a lot of bullshit. Yeah, I know. I also read that there are unicorns in the hills. Doesn't mean it's true. Most scientists are very leery to draw a direct causation between tech and ADHD onset just because it's really bad for your career. But trust me, the data is 100% there. It's not even close at this point. Like, yeah. Sadie, what are you thinking? Was that you?
Okay, Sadie, I just have a question since you've opened it.
Yeah.
How does neurodiversity impact this, or does it, or is that a bigger conversation?
No, it doesn't. That's the good news is. So when it comes to learning and basic mechanisms like this, if you're a human being, you're going through the same process. Here's one of the weirdest things I have to teach. Everyone learns in exactly the same way. Everyone develops in exactly the same way. The inputs, what we need to push through that process will change. So if you think about it, everyone digests the same way. Does anyone have a problem with that? Of course not, because it's common sense. No one has 3 stomachs and chews cud. No one spits acid. And we all have one system. Now, some people are missing parts of that system. We have to compensate. Some people can only put certain things through the system, but the system doesn't change. It's the same thing with, this is why I love this so much. Learning, development, it's all the same. It's just what inputs do we need? What supports or scaffolds do we need to get through this process? That will change. And that's where we move from development into pedagogy. And that's where I step away, because that's when teachers come in and say, here's our expertise. We know how to teach, how to walk people through this process. I only know the process. Yeah. No, I love it. Thank you. That's an awesome question. Yeah.
Does the quality of sleep or the number of hours of sleep affect the synapses?
100%. A good thing what you're doing when you're asleep is your brain is pulling back synapses that it made that day. Typically when you're awake, you're going to be building synapses. Typically when you're asleep, now you pull it back to kind of normal levels. And that's where your brain will hold on to certain ones, say this is good, oh this was good, but we don't need all this extra stuff, it's just noise. You don't get enough sleep, you get a noisy brain. And all of a sudden you have too much communication going on. You have too much talking. You can't really parse out what's important, what's not. You get less sleep the next night, you get more noise. It'll get to the point where if you get too much noise in there, your brain will knock you out. It will, and that's why if you don't sleep for 72 hours or so, you will just pass out because your brain is too noisy. It can't cohere anything anymore. And then it'll pull back some of those synapses. So absolutely, sleep is as much a part of learning and development as anything else you're gonna do. Like when my kids say, how do I learn? That is one of the key principles. You go to sleep. You do a lot of your learning when you're asleep. You don't sleep, you find the rest of it just kind of goes haywire. That's awesome thinking. Yeah. When we look at what?
If you look at the way the brain
Yep.
the brain is developing, if there's, say, a state of chronic sleep deprivation, is it?
We will see the same so long as you hit puberty, we'll see this pattern happening. But then the sleep deprivation can change what you're doing in there and can prolong it as well. It's harder to get out of it when you're not in any position to take responsibility. I love this. You're all thinking wonderfully about, this is y'all, my people. Usually the questions I get are yeah, when do I get my kid a phone? Which is fine, that's a good question, I love it. By the way, do you know what the answer to that question is? I heard the best answer to that question, a woman named Emily Shurkin from Seattle. Someone asked her, when do I give my kid a cell phone? Her answer? When are you ready for them to start watching porn? It's the first thing they're gonna do. And she's absolutely right. Does not matter what age you give them a phone. The first thing they will search for when you're not around, boobies. I'm not. So your choice. That is and no offense, what's the first thing we all did when we had tech? It's the same thing. They're not different than us. They're going to run it the same way we did. And so then the question becomes, all right, take that off the table. When do you get it for them? when they're ready to buy it. Why would I buy it? Like, I've got a kid growing up. When are you going to get him a cell phone when she can afford it? I ain't buying her one. You get what? It's like giving my kid heroin. Yeah. Let me help you with that. Here's some cigarettes, too. Smoke these. So here's our certain things you let them discover. Here is, ooh, shit just got tense in this room. I love it. Here is our kind of brain development. So we start out, we come out of the womb, our brain is still kind of growing. We go into pure bottom-up processing where we get this synaptic explosion. It's world-driven. It's pure experience. What do I hear? What do I see? What do I smell? That's building in there. We then hit synaptic pruning. This is when the brain starts to organize. I'll do this. I'll do this. I need to talk to you. Don't need to talk to you. When the brain kind of gets heavily organized, that's when the prefrontal cortex says, cool, now I got to learn how to drive this. Bang. It starts turning off way too much. Nucleus accumbens overcompensates. Now we get this kind of push into adult levels where we get this even world-driven, me-driven processing, and now we can kind of do what we think of as adult thinking. I can engage with the world and push back in my own way. Now, before we move into the stress question real fast, I'd be remiss if I didn't point out what are some levels of support at this stage. Now, these are research-driven, so take these with a grain of salt. If what I says resonates, use it. If what I say doesn't resonate, ditch it. Ditch my data 10 days out of 10. For your own experiences. Only you know your kids, only you know your family, and that is more important than anything anyone will do in a lab. So just keep that in mind. So what are some levels of support? Number one thing we found in a lab is this. I know I picked the wrong image, but really it could be any of them. Never, ever engage in a debate with a teenager. Do not do it. The joke is, by all means, we can talk to them, we can argue with them, but once you reach that threshold where we enter into debate, where there will be a right and a wrong person at the end of this, it's over. You're done. Go home. Now, the reason for this is simple. Oh, sorry. This has been a long day. I apologize. Have a good night. The reason for this is clear. When we debate as adults, we use a very specific rule set. It's called intellectual jousting. You make a point, I make a counterpoint. Whoever can make the other person's argument crumble fastest wins the debate. Congratulations. When teenagers debate, they do not use that rule set. They use what's called the emotional browbeating rule set. I will try and make you cry, you try and make me cry. Whoever can make the other person cry fastest wins. When I pit my intellectual jousting rule set against your emotional destruction rule set, what wins every time? That. And they don't even understand our rules. So when we debate a teenager, we have to play by their rules, and they are so much better at making us cry than we are making them cry. So we never engage in a debate with teenagers. How do we avoid that? Again, we talk to them, we discuss, you can argue, you push back, sweet. It's just when we hit that debate stage. How do you stop it? It's there. Clear rules, clear processes, clear consequences. When you have a set of rules, that's how you offload ever having to do this. So when I used to teach high school, the first couple days of every year, we'd build a class rule set. If you speak out in class, what do you do? If you don't hand in homework, what happens? If you bully someone, what's going to happen? They're building it with me. We're doing it together. And they're bored out of their mind. And they're like, why do we got to do this? Because I know in about 1 month, one of y'all is going to try this. And as soon as you try this, all I got to do is point to this. Oh, but sir, you don't understand. You know the rule, get in the hall. Oh, but no, you're not listening to me. You know the rule, get out in the hall. Oh, but no, you got to give me one more day. You know the rule, get out in the hall. Now, in the moment when you use rules to avoid a debate, oh, you are the heavy. Your kid is going to hate you. But given 2, 3, 4 hours, once they start to calm down, watch what's going to happen. They're going to take a lot of that blame off of you, and they're going to put a lot of it right there. They're going to say a lot less, I hate you, a lot more, I hate these rules. Well, sweet. I'm happy to change those rules. We can talk about that anytime. The one thing I'm not going to do is this. So the more we in advance have our rule set in place, that's how we avoid going down that path of, uh-oh, we're now pushing into a wrong right. No, we're not doing that today. Here's what we're going to do. Yeah.
But that's nice. But if they don't respect the rules, then we go and debate.
Oh, at that point, then you're the parent. No, there's no more debate. Now we crack down. Now we say, oh, you don't respect my rules? I'm going to make harder rules then. We could build rules together, but if you start pushing back against the rules that we built together, I'm going to start making the rules now, and they're going to be crappy. And that's going to help them start to, again, they're going to, now your kids will always push back against you, but that's how we try, and the more standards we have, that's where they get to bounce things against. I know, and I wish, man, some kids are going to push back. It just is what it's going to be. But this is, if we can kind of think along these lines. And now we'll change it. Again, kids will say, I want to stay out later. Cool, let's talk about that. That's a discussion. That's not a debate. Give me the reasons for it. I'll give you the reasons why not. We'll see who wins. Cool, let's, why don't we compromise? We'll say, let's go 9:30. Does that sound good to you? Sweet, let's do it. We'll discuss. We can always change rules together. It's just once we get into the, you're wrong, I'm right stuff. It's just, it doesn't work with them. They don't understand what we're trying to do. By the way, that brings us here. So relationships become all important during this stage. You know this. And two things here. One, when I talk about relationships here, the primary one seems to be the relationship with a kid to home, or whatever home looks like to them. In any culture where school life and home life bleed together completely, we see massive surges in mental and emotional disturbances. So think like South Korea is a really big problem where basically home is school. You're always doing school. So how do we help them recognize some sort of cutoff point where here you're doing this, here you can act somewhat differently. You can tell different jokes, you can act differently. By all means, we're still doing homework, we're talking about school, but somehow this is a different world than this. Having that kind of cutoff point where you know I can do different things here seems to be very helpful. And the other thing I'll say too is here, if your kids yell at you and say, I hate you, take a modicum of pride in that. Like, don't let them get away with it. I'll be like, oh, cool, I hope you hate me from your room. Enjoy that one. But if they say that, you know who they'll never say I hate you to? Me. Because they don't know me enough. They don't feel safe enough around me. They don't feel like they can do that, so they don't. But if they feel like they can do that to you, that means you've built enough of a relationship with them that they feel safe enough to try this crap out on. Like, let me try, how far can I push you? What can I do with you? And so again, we don't let them get away with anything, but take a little bit of pride in like, okay, this kid feels safe enough. The scariest thing, now some kids will never say I hate you. Some kids are awesome, wonderful. But the scariest is the teenager who does not feel safe enough to even push against a parent. That's when I'm like, uh-oh. Because that's usually, there's a really highly aggressive someone in the house that the kid doesn't feel safe around, or they don't feel, so if you're getting that kind of pushback, cool, they're supposed to do that. We're not letting it all happen all the time, but that's kind of the game. Finally, I'd say allow choice. If the entire purpose of adolescence is to learn how to drive this machine, then they have to have a sense that they're driving this machine. So where can we give them choices? And they don't have to be big choices. You pick the restaurant tonight. Pick what movie we're going to watch tonight. What do you want to do? These things are trivial to us, but it's to them, it gives them that sense of control, agency, and starts to give them that sense of adult responsibility. And again, as they get older, they can take more and more and more choices. But so just know that that's kind of the thing that's bringing them into that adult level. And finally, if you have high schoolers, ask them about what I taught them this morning about the impact of story. All I'll say is story is everything. We can tap into theirs, but they cannot tap into ours. They will never understand ours, but we do have a chance to understand theirs because we've been there. So the more we can embrace their story, get into their nitty-gritty, that's where we're going to find the clues we need to bring them one step up, rather than trying to quantum leap them. Why aren't you acting more like an adult? So ask your kids about the power of story, and then that's how we kind of, what is their story? What are they seeing, smelling, tasting? That's where we'll find our kind of cues. Now, two final things I want to teach you tonight. One is this. I want to take a look at stress, because during adolescence especially, this is one of those kind of primary things that we see, stress. So I want us to see what is one of the mechanisms of stress. There are other ones. This is just a primary one. And what impact is that having? So what I want to do is I want to show you a quick graph. On this side, we're going to take a look at learning or performance or ability from low to high. On this side, we're taking a look at stress duration. So what happens when our kids' sense of stress goes from minutes to hours to days to weeks to months? As stress duration increases, learning and performance does this. You get an inverted U. Low duration bad, long duration bad, moderate duration very good. Now, why would this be? To understand, I want to weave you a quick story. So our story takes place here in the hippocampus. Now the hippocampus, just to be simple, we're going to say this is your memory center. Anytime you've learned anything new, that information has made it through your hippocampus. So think of the hippocampus like a lush forest, and each little cell in there is an individual tree. Cool. Bad guy in our story is cortisol. Anytime you select stress, cortisol is one of the first chemicals to be released. Since that's the bad guy, we're going to say that's a barbarian horde. I just hate things. Good guy in our story is going to be ARC proteins. ARC proteins is synthesized in a part of your brain called the amygdala. Since that's the good guy, we're going to say that's a knight in shining armor. Dun, 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 dun. Cool. So what happens? Why would moderate duration stress be good for learning and performance? Well, you're kicking it when all of a sudden you select stress. Now, what's one of the first chemicals to be released when you select stress? Cortisol. And in your body, cortisol does a lot of things. It goes to your heart, goes to your ribs, goes to your muscles. Cool. In your brain, it largely goes to one spot. It goes to your memory center, where it is neurotoxic. Cortisol will kill your hippocampus. Now, anytime cortisol starts killing and damaging cells in your hippocampus, that will trigger the release of ARC proteins. ARC proteins will go flooding into your brain, and they will basically fight with cortisol. They will keep them busy. So long as they're fighting, not a lot of damage can be done. Now remember, we're talking about moderate stress here. So maybe it's been 3 hours, 4 hours, 5 hours, the stress is done. Cortisol stops flushing in, ARC proteins win the day, great. Here's where it gets good. Before ARC proteins go back to the amygdala, go about their business, they're now going to go up to any cell, any tree that was damaged by cortisol, and they're going to upregulate it. They're going to make that cell stronger. In a very real sense, you are going to come out with a better memory than when you went in. We call this the agitation method. Why? There he is, water in the tree. Why would we have a mechanism that says if you select stress, we're going to make sure you have a deep memory for that thing? What function does that serve? It's a safety thing. Stress is so rare that we have a mechanism that says, cool, if you select stress, we're going to make sure you remember that. So if you ever see stress again in the future, you're going to know exactly what to do. Yep, yep.
Sorry, just that timeline that you had, moderate stress is a few hours?
So once we get into long duration stress, this is about 72 hours and beyond. So moderate duration will be anywhere from hours to about 3 days, seems to be the window. 72 hours is when everything kind of shifts. So that's accent. In South Africa, cool. Sorry, my wife is from Australia, so I was thinking, you're close, but nice. That's awesome to meet you. So here we go. Why would long duration stress be so bad? So you're kicking it, you select stress. Cortisol rushes in. ARC proteins rush in, they fight. Cortisol loses, but wait, you keep selecting stress. More cortisol rushes in. Fight. Cortisol loses, but wait, you keep selecting stress. More cortisol rushes in. It's at about the 72-hour mark where you will run out of ARC proteins. Your body can synthesize cortisol much faster than it can ARC proteins. So at about the 72-hour mark, when you run out of ARC proteins, cortisol wins, and then it kills your memory center. It will basically shut your learning off. You will not build memories. Why? It's the exact same mechanism. Why at about the 3-day mark would it flip to let's make deep memories to let's make no memories? What function does that serve? That's your protection mechanism. This is your way to protect against trauma. Your brain assumes if you hit about 3 days of stress, you must be trapped. You must be helpless. If you're still in stress, you're out. In which case, it takes you out of the equation. It says, cool, we'll take you out, we'll bring you back in once you're out of this thing. So this is like, I imagine like if you step in a bear trap, in the moment, you're going to make a deep memory for that bear trap. You're not doing that again. But let's say you can't get out of that bear trap for 6 days. Do you really need a deep, durable, lasting memory for those 6 days of pain? Like, oh, this is great. No, at about the 3-day mark, your brain's like, you're not moving? Sweet. We're going to get you out of here till you're out of the situation. Then we'll bring you back online. It's there to protect us against trauma. Why then, by the way, would low duration stress be just as bad? Well, you're kicking it when all of a sudden, nothing happens. But then when you least expect it, nothing happens. If nothing happens and you retire and just yell at the TV all night, what's going to happen? Brain's like, sweet, why would I waste any energy up here? I'm gone. So that's why low duration can be just as bad as long duration. If you do nothing, your brain will pull itself back as surely as if something else is trying to attack it. So this means moderate stress is very good for learning and performance and development. So what does moderate stress look like? These are things like challenge. High expectations, not letting kids get away with easy answers. Let's push a little harder today. This is like if you're tracking your growth and progression and you're setting little goals. Like, let's say you're practicing golf and you did 90 yards today. Tomorrow, let's see if I can't do 91. You set these little goals. Those are the minor stressors that force you to push the system a little harder. Clear rules, consistent repercussions. Having something to bounce something against, that's a moderate stressor. Good kind of rule. Tension plus uncertainty equals fear. Tension plus certainty is an acute stress. If I screw up and I don't know what's going to happen, I don't really learn from that. It's just kind of frightening. But if I screw up and I know exactly what's going to happen if I get busted, now it's an acute stress. Now it's a game. Now I'm trying something out here, and I'm going to learn from what the heck happens. So structure helps us build these moderate stressors day in, day out that allows kids to bounce things off of and learn and grow. Chronic stress, that's the bad guy. So if we worry that a kid has hit chronic stress, like maybe during COVID lockdown it happened, maybe during a very intense family period or period at school, you've crossed that threshold. If we worry a kid has gone into chronic stress, the first port of call is here. Oh, wait, sorry, there. Relationships. It is now back to square one. You need to stop, like the kid will not learn. Like I was working in Australia, we were taking in a lot of refugees for a while. And the argument was, do you put them in class? What do you do with them? You do not put them in class. You spend your time just trying to build a relationship with them. Once a kid feels safe enough around another human being, then they can stop selecting stress. Then we can get the machinery back on. Then we can say, cool, what do we want to learn? But that's, so long as they're in that stress, learning really isn't a priority for the brain. And by the way, I'll tell you how deep this gets. I didn't even know how real it was till it happened to me. So I was in Melbourne for COVID, so we had the world's 2 longest lockdowns. Hooray for us. During the first one, everyone was kind of fine. During the second one, I didn't even know. If you're in chronic stress, most of the time you don't know. I read sci-fi books. So good rule of thumb, if you read 1 sci-fi book, you will read 3 sci-fi books. There's always a trilogy. For some reason, they refuse to just do 1. So COVID's over, we're going about our business. I read this new trilogy like a year ago, and I show it to my wife. I'm like, damn, this is really good. You should read this. She's like, oh, yeah, you really liked it the first time you read it, too. She walked me to my bookshelf. Sure enough, there they were with my notes in them. Nothing. Not even a thing. I didn't know how powerful that was until I read 3 books, noted them, didn't even know. I was in chronic stress. I was not making memories at all. That's why if you were stressed out during COVID, that's why COVID in hindsight feels so short. We don't remember anything because if you were in chronic stress, you remember the big bits. That's about as far as you're going to get. So how do we deal with relationships? And then we'll move into our final session for the night. This is your guru for relationships, John Gottman. Has anyone heard of him? Dude's a stud. So he spent about 50 years studying relationships, and he started with just marriages, and he came out with the 7 principles of successful marriages. But then he went into, let's look at bosses and employees, same principles. Coaches and teams, same principles. Teachers and students, same principles. So it's now the 7 principles of any successful relationship. So I won't go into those deeply here tonight, but I just know if you want to kind of look up what are some key aspects to think about in a relationship, this is the guy to turn to. Look up John Gottman's 7 principles. You will find all the stuff you need on it. And that's how we might need to navigate. If we think our kid has gone into chronic stress, let's go back to square one, start doing some of these things again. Now, here's where I want to tail out with us tonight. Uh-oh. Have you guys heard of this thing called technology? I hear it's pretty prominent. I don't know. Now, before I talk about tech, I'll give you a fair warning. I am an absolute card-carrying Luddite. I hate digital technology. I think it is a net loss for humanity. I think for all the good it's given us far worse, and I would take it all back if I could right now. If that means I couldn't be here with you, fine, so be it. I hate it. I think it's ridiculous, and it will be the end of us. Well, it will be the end of what we always wanted from each other. But that's where I come from. So just know anytime I talk about tech, that's the lens through which I speak. So take everything with that caveat as we go through this. With that said, I don't really need to because I'm going to talk data, so you can still take it all as needed. When our kids use tech, there are 3 very important things we got to remember. 1, relationships go down. There is this really wicked argument that's been going on for decades that says tech is bringing us together. Tech is how we interact. Tech is bringing the world, making us smaller. No, the one thing tech does is it drives a wedge right through people. It does not bring you together, it separates you. Why? The reason is when we interact live and in person, our body releases a chemical called oxytocin. So just to be simple, we're going to call that a bonding chemical. It does a lot more, but you'll see a lot of it when you're breastfeeding, oxytocin. When you're making love, oxytocin. When you're interacting positively with someone live and in person, oxytocin. When you interact with someone online, the brain does not release oxytocin, it releases tachykinins. Tachykinins are the protein precursor to depression. In a very real sense, if I know the concentration of tachykinins in your blood, specifically TAC2, I can tell you how close you are to being diagnosed with depression. It's almost a one-to-one shot. This means human biology does not recognize text-based communication as interaction. It recognizes it as threatening and isolating. So the more our kids interact online, the more lonely they start to feel. Now, when you start to feel lonely, what's the first thing you do? You reach out to more people. In this instance, you're going to now feel lonelier. So what do? You reach out to more people, and now you feel lonelier. It's one of these wicked things where we keep trying to use the poison for the cure, and it just ain't going to work. So it doesn't matter. In fact, the more friends your kids have online, the more tac they have in their blood. There's almost a shot of like, the more people you interact with on social media, the more lonely and isolated you start to feel. It's a really wicked situation. So just know, tech does not bring us closer together, and it is not helping your kids' relationship. And what did we just see was the primary way to deal with chronic stress? You need strong relationships. You ain't going to get them here. So that leads us to step 2. The more your kids use tech, the more their relationships go down, but their stress goes up. Now, why is this? This has to do with what's called the habit cycle. So habits are simple. Here's how a habit works. Something in the world has to grab your attention. So let's say your cell phone dings. That grabs your attention. We call those things cues. In response to a cue, you can now undertake an action. Ding, oh, maybe I'll check my emails. Anytime you undertake a successful action in response to a cue, your brain will give you a hit of dopamine, you will feel good. Cue, action, reward. Cue, action, reward. Cue, action, reward. Now, your brain's not stupid. You do this enough in the same order, eventually your brain is going to preempt you. Your brain's going to go cue, oh, I know what's coming. And it's going to spit out your dopamine here before you've done anything. Now, here's the trick. You get dopamine here after you've done an action, it feels good. You get dopamine here before you've done an action, it does not feel good. It does not feel rewarding. It feels like a craving. It feels like an urge. Now you have to undertake the action just to calm the system down and regain a sense of homeostasis. So once we move from cue, action, reward to cue, reward, action, you have now built a habit. Say habit, I'll bet I could use a different term for that. What is it? Addiction. That is the addiction cycle. When we say people are addicted to their cell phones, this is what we mean. They've built a habit cycle that forces you to use that tech just to calm down. Now, the trick is, a lot of kids, when you tell them this, they're like, oh, I could beat that. Like, now that I know the system, I can turn off my dings. I win. No. No one can beat it. We are paying the best minds in the world right now, the highest salaries in the history of mankind, to do one thing: build habit cycles in tech. Man, they're not even hiding it anymore. For a while, tech was pretending they were our friend. Like, hey, this is for you. This is for school. I don't know why they became Italian all of a sudden. This is all for you. But they were pretending like they loved us. They are flat out not even hiding it anymore. They're like, yep, we got one job. That's to keep your eyes on our phone. We are trying to build habit cycles. The greatest minds in the world, imagine if we paid the highest salaries to the greatest minds to clean up the ocean or to fix the environment. That shit would have been done a decade ago. Nope, we're paying them for this. Why? Because that's where the money is, that's where the power is. So even if your kid manages to beat one habit cycle, man, there are 99 right on its tail. It's going to get you. No one can beat this. And you see it when you realize kids check their phone on average 155 times a day. That's once every 7 minutes. Oh, wait, that's not kids. That's y'all. Yep. No one can beat it. We are all trapped by this stuff. And the more habit cycles, the more addictions you get, the more chronic stress you start to feel. When you move into chronic stress, you need relationships. So you go back to your tech to try, you start to see how this all feeds into a very negative loop. Things are not going well with this stuff. But okay, so the more I use tech, my relationships go down, my stress goes up, and here's the big dog, your learning will go down. I do not know how much more data we need. We have over 4 decades of data showing that when you include digital technology in learning, learning goes down. Now, I'm not the only one who says this. OECD, students who use computers very frequently at school do a lot worse in most learning outcomes. JPAL, International Research Organization, computers do not improve K through 12 grades and test scores. Online courses lower academic achievement compared to in-person courses. Here's a paper published last year. It was the biggest paper ever done with primary year students in the US. 145,000 kids looking at the impact of tech and literacy. Even small daily amounts of digital device in class, 30 minutes, are negatively related to scores on reading and comprehension tests. Let's go to the other side, tertiary, university sector. Here's a paper published that looked at 125 moderators at the university level, moderators for learning. Hands down the worst, digital technology. Expanding the use of digital technology at the expense of any other form of instruction is likely to have detrimental effects on achievement. Any other form of instruction? Here are 2 papers published last year, one that shows if you invest in air conditioning, you will get better learning than if you invest in one-to-one computers for every child. Larry Cuban, he is the ed tech guru from Stanford, recently said computers were supposed to improve academic achievement and alter how teachers taught. Neither of these things has occurred. Here's the thing that really does my head in, and we were talking about this earlier. Larry Cuban, he is still pro-tech. He's arguing you're just using it wrong, y'all. You gotta learn to use it better. JPAL, still pro-tech. We need more tech in schools. You're all just using it wrong. Use it better. OECD, still pro-tech. You're all using it wrong. Man, if I had 4 decades of data showing that cigarette smoking harms your lungs, the proper response isn't, you're smoking wrong. I need you to smoke better. Just smoke better. You're fine. The proper response is to say, what the heck is going on? Is this fixable? And if the answer is no, then we got to rethink what it is we're doing. So what is the problem? The problem, and I got to put this slide up, what's happening with this? The problem with digital tech concerns what's called primary function. So every tool in this world has a primary function. That says when you pick up that tool, what's the first story that pops in your mind about how you need to be using that tool? So think of a hammer. Dozen things you can do with a hammer. You can scratch your back. You can pop a bottle cap. You can twist something into a wall. You can throw it at a bird. You can paperweight it. Whatever you want to do. Dozens of things you can do. But 90% of the time, 90% of us use a hammer to hit things. So as soon as I give you that tool, the story pops in your mind. Cool, what do you want me to hit? So what is the primary function of a computer? When a kid sits down in front of a computer or a screen and we say time to learn, what's the first story that pops into their mind about how they're supposed to be using this tool? Well, let's see if we can't find out. Now, real quick, I'm going to have to skip this, sorry, just in the interest of time. But I want to play a quick game with you. Here's how this game works. I'm going to set my timer for 10 seconds. Now, when I say go, you're going to have 2 jobs for me. So you can just use your finger, and you can write on your palm, or you can write on your knee, or the chair in front of you. We don't need a pen and paper. We'll go analog here. When I say go, the first thing I want you to do is write out the first 12 letters of the alphabet as quickly as you can. So A, B, C, D, E, F, G, H, I, J, K, L, up to L. When you're done doing that, I then want you to write out the first 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to give you 10 seconds to see, can you do all that? Can you give me 12 letters, then 12 numbers? Or let's see how far along that process you can get. All right. And, oh, that was the wrong one. Here we go. And, ready, set, go. Stop. How do we do? Some people finished. Did a lot of you, most people get close, like 7, 8, 9, oh, all right, perfect. Let's do that same game again. I love it. We're going to do the same thing. I'm going to give you 10 seconds. You're going to give me 12 letters and 12 numbers. Except this time, let's switch it up. Instead of doing 12 letters and 12 numbers, I want you to jump between the 2. So first I want you to write the letter A, then the number 1, then the letter B, then the number 2. Same thing, we're just doing 12 letters, 12 numbers. All we're doing is jumping. 10 seconds. Let's see what happens this time. All right, and ready, set, go. Stop. And how did we do that time? Now, if you're like most people, you didn't get anywhere near as far that second. Like most people only get about 2/3. But more importantly, how many of you started to get a bit confused? Yeah, like, look, it's just letters and numbers, but by the time you get up to E, you're going, A, B, C, D, E, F, F, A, B, C, D, E, F, G. So, wait a second, why was that so difficult? Welcome, ladies and gentlemen, to the wonderful world of multitasking. You can't do it. No human being in the world can do it. Multitasking is not a skill issue. It's not a software issue that says if I just practice good enough, I can develop this ability. No, multitasking is a brain problem. Now, we didn't get a chance to talk about attention, but attention, the best way to think about attention is kind of like a filter, right? That deems what's relevant, makes it into your awareness, you can learn it. What's irrelevant gets blocked out. The problem is you only have one attention filter slot in your brain. It's a little nugget here behind your left eye. So this means anytime you want to do two things at once, you can't do them simultaneously. The best you can do is start one, take that filter out, put it back in, jump to this one. Take that filter out, back to the old one, go to this one. Now, swapping your filter takes time. It takes about 0.2 seconds, during which time your brain goes black. That's why we were going slower. Also, every time you swap your filter, your brain dumps about a half second of incoming information. Whatever you were just doing, your brain assumes if you're jumping, it must be irrelevant, and it gets rid of it. This is why we started to get confused. Once you get out of any simple pattern, you have to keep starting from scratch because your brain's like, what were we doing? You got to go back to the beginning. I ain't even going to pull this punch. Multitasking, the single worst thing human beings can do for learning and memory. When you multitask, you will go slower, your accuracy will drop, and your memory will tank significantly. Now we can go back here. What is the primary function of a computer? When a kid sits down in front of a computer and we say time to learn, what do they think they need to be doing? Let's see if we can't figure it out. Here is the breakdown per week of how teens and tweens 8 to 18 use computers. Now this was pre-COVID, the year before COVID. During COVID, all these values shot up, but the ratio stayed the same, which should scare the daylights out of anyone. Since COVID's done, the values are coming down, but the ratios are still there. The values are all higher than they used to be, but the ratio stays the same. So just keep that in mind. Here we go. What do we got? 10 hours, 45 minutes playing video games. 10 hours watching TV, video, YouTube, Netflix, all that fun stuff. 8 hours, 15 scrolling social media, 7.5 listening to music, 3.5 doing homework. Nice work, kids. 2 doing schoolwork, 1:15 reading for pleasure, 1 hour creating actual content, a whopping 15 minutes writing for pleasure. When you extrapolate this and you remember that school is only in session for 180 days per year, this means per year your kids will use computers for learning purposes about 200 hours, which is really impressive. Until you realize they will use the same exact tool to passively consume rapidly switching media content for over 2,000 hours a year. How do 90% of kids spend 90% of their time using a tool? I think we just found our primary function. And I'll bet I could sum this up. Passive consumption of rapidly switching media content, I bet I could sum that up in a single word. What is it? Multitasking. Absolutely. What is scrolling but multitasking? What did we just learn is the single worst thing you can do for learning? What is the one thing kids have spent thousands of hours a year training themselves to do on these machines? Is it any wonder they are so bad at learning on it? This is why when your kid sits down to do homework on a computer, they will make it about 6 minutes before they start multitasking, during which time homework is done. When they sit down for live digital lessons, most will make it about 15 minutes, but by the end of the second lockdown in Melbourne, the average was 2 minutes. Kids were making it before they started multitasking. That meant over half of our kids were logging on, waving at us, then immediately going and doing something else. When your kids use computers during class, 38 minutes of every hour will be off task. 60 minutes of every hour will be off-task multitasking. So I want us to recognize nobody has ever argued that computers can't be used for learning. That's not an argument. Literally everything can be used for learning. This podium can be used for learning. My shoe can be used for learning. The argument is that computers so often aren't used for learning that now when we try and shoehorn that function in, we've got this massive hurdle that kids got to overcome, and the vast majority of them simply can't do it. This is why tech is bad in schools. And just so you don't think I'm crazy, Sweden just banned tech from schools. Not a school, not a cell phone, they banned tech from schools across Sweden. Finland is about to do the same thing next month, I think. Why? They're following the data. you couldn't get any more clear than we already are. Tech doesn't work. Now, how is my kid ever going to learn to use AI? You mean aside from the 2,000 hours they're practicing it there? Trust me, they'll learn how to use it, but we still keep a computer lab at school. You still teach kids how to use a computer, that's fine. You just don't teach everything through a computer. It is one thing to teach you how to use it. It is one thing to enforce that thing in areas where it doesn't belong. So anytime you can log off or ask your kids to log off, do it. If they can read a hard copy versus a digital copy, they will learn more, remember better, comprehend better. All because of the medium they're using. Buy a printer, print it out. If they write by hand versus typing, they will remember more. If they play with manipulatives as opposed to a screen, they will remember, comprehend more. It's just the tool itself is so detrimental right now to learning. Now, if you can lock the tool down, fine, but I don't think any of us can do that. Kids are so much better at unlocking tools than we are locking them, so I don't think that's going to be an option for most of us. Now, just so you don't think it's all doom and gloom, when do computers work? Something is better than nothing. That becomes your motto. You got a specific learning disability and you can't learn without tech? Something is better than nothing. Of course you use tech. You're an F1 driver and you can't shut down Monaco to practice your laps? Of course you use tech. Something is better than nothing. There is a global pandemic and we shut schools. That'll never happen, but just, theoretically, you use tech. But the trick is, if you do have a choice, you always pick the option that's stronger for your outcome, in this case learning, which is never going to be tech. So all right, that is where I'm going to leave it with you all. Real quick, just if you want to know a little bit more, I'm sorry I took you right up to 8. Just a few more resources. If you look me up, Jared Cooney Horvath on YouTube, I put out learning videos every couple weeks, so just know that's an option. This book is the most learning-centered book I've written, so if you want to know some more specific strategies for your students when it comes to learning, just know that book is a good one for just learning practices. Other than that, thank you guys so much for hanging out. I'm happy to stick around and chat, but I took you up to the end, so run, frolic, be free. Thank you guys for coming, and I'll see you later. Yay, thank you.